All right, ladies, I promised to create a video for this example that I did not do in class today. So this is a calculator technique for calculator required free response question. So let's start off by clearing our calculator in case there were some things that you altered earlier, like say your window. So you can always clear everything that was entered, and my stat students used some of my calculators, and of course we use the stat edit function. Okay, so how to clear? You press second plus 712, reset that into its original setting. So let's first read the question. It says here, the function f is defined on the open interval 0.4 to 2.4. This is important because this is where I'm going to create or change my window. I'm going to use that for my window because they only want us to observe the graph from this part to this part. Okay, now it has a first derivative of f prime that's given. F prime is equal to sine x squared. So when I do problems like this, I like to annotate so that I will be reminded on what things I needed to do in my calculator. So first, I need to enter the given f prime. F prime is sine x squared. So enter that using y equals, enter sine. X is right here, square is down here, close, and then change your window. Because if I press graph, I will see an oscillating graph, and I don't want to look at everything in there because they specified that we only wanted to observe 0.4 up to 2.4. So graph that, and this is now what I needed to see. Now, if I look at my graph, it looks like there's a lot of space at the top and a lot of space at the bottom. We can still change your window. The y min and y max may be -3 to +3 so that it's a little bigger than the first one. Can I continue doing that? Yes, you can keep on changing -2 to 2 so that you get a nicer graph. -1 to 1. Hey, go ahead and do that if you like. So first question. I need to identify the intervals from where to where the graph of f, this is actually f, is increasing and concave down. So how do I know where the original function f is increasing and concave down when I'm given an f prime? So when I'm given problems like this, I will annotate, oh, f of x is increasing when f prime is positive. So I will look at the graph where it is above the x-axis. Now, what happens to concave down? How do I know my original function is concave down? So f is concave down when the first derivative is decreasing. Because if the first derivative is decreasing, this also means that the second derivative is less than 0. So second derivative less than 0 means f is concave down. So look for those two in the graph. I wanted to find out where the derivative, this is our f prime, the derivative, first derivative graph is above the x-axis and decreasing. So if I take a look at the portions of each graph, I see a part where it is increasing above the x-axis. This is the x-axis right here. The graph at the top is what I'm looking at. This is increasing, and then this part right here is decreasing, and this is below the x-axis. So this part right here, I know that will tell me the f is decreasing. So I will only look at it from here. What part of the graph is f increasing and concave down? What part of f prime? Is it above the x-axis but decreasing? So this is increasing and I see a decreasing part here. So I want to know where this one is that starts to decrease and stops over here above the x-axis. So how do I get that? That's a maximum. Just use second trace maximum to find that point, the maximum point. Now it's asking for left bound. So if the maximum is somewhere over here, I need to move my cursor before the maximum. So I see it's less than that maximum part. And then right cursor to the right of the maximum. Why am I doing this? Calculator cannot guess what part you wanted to do. So you must be able to identify that I only want the calculator to solve it between these two lines. And then it's asking for guess, press enter, and it should give you your maximum. So the maximum part right there, I'm gonna just copy it. I have 1.2533142. Okay, that's where my graph starts to decrease. My F prime graph starts to decrease. Now, I also want to find this point right here because that is the point where my graph, my F function stops increasing. So I'm going to do second trace, 0 this time because that is an x-intercept. Go all the way closer to 0. It's asking for left bound, so I can use that as my left bound. Can I move closer? Yes. Next time, right. Next one is right bound, so move the cursor after the 0, and the calculator will calculate where the graph crosses the x-axis if you bound it like that. Press enter. The 0 is 1.77245. 1.77245. And all those numbers or decimals. Now, when we're reading, we're only actually looking at the 3 decimals after the 3 digits after the decimal. Okay, or the 3 numbers after the decimal. That's all we needed to see. So how will I justify this if they ask you to justify? Although this one is not asking you to justify your answer, but I'm still going to do that anyway in case. I will say F is increasing. So always state what the question is. They want you to identify where is F increasing and concave down. So I'm just going to rewrite that. F is increasing and concave down in what interval? 1.253. Can I stop there? Yes. 1.772. And what's going on here? Why is it increasing concave down for F here? Because F prime, so if they want you to prove something about F and they gave you a graph of F prime, you have to use F prime in your reasoning because F prime is, what's going on with F prime? Decreasing. What else? And greater than 0. Okay, here. So F prime decreasing, that's for concave down. F is increasing. F prime greater than 0, that means F is increasing. Period. You don't need to say a lot of things. Just be specific. And another thing that I need you to not say is don't say it is increasing, because what does it mean? It can mean F, F prime, or F double prime. Okay, don't say the function because F prime is a function, F is a function, and F double prime is also a function. So you have to be specific. Okay. Next one, identify the X value where F of X has a relative maximum. So when does this happen? F has a relative maximum when F prime is equal to 0. And then you need to check the signs for before and after that 0, whatever that 0 is, and check for positive and negative signs. Because what's going on over here? If my F prime changes from positive to negative sign, this tells me that my original function is changing from increasing to decreasing. So if my function is changing from increasing to decreasing, this part right here will be a maximum. Okay, another way to say it, or to look at it, is think of the tangent line slopes. The tangent line slopes here are all positive. The tangent line slope here is 0, and the tangent line slope here is negative. That's why we get this number. So this is a 0 for the first derivative, or undefined if your function has, if your first derivative can get an undefined value wherever x is undefined. Okay, so let's take a look at the graph again. And I want to find the 0. This is my f prime. And look at the graph. I want to look for where is f prime 0. So I'm going to say f prime is equal to 0 at what x? We've solved this already. Second trace 0 was 1.7724. Okay, f prime of x is 0 at this x. And then I'll say f has a maximum, relative maximum, at x equals 1.77245, because what is going on with your f prime? F prime changes from above the x-axis, which is positive signs, to below the x-axis, which becomes negative signs. So you say f prime changes from positive to negative at this x, period. Okay, that's your justification. Your answer will be this one. But you have to be specific. You want the max of f, not the max of f prime. So f has a max at this x, because that is where your first derivative is equal to 0, meaning your f function changes from increasing at the top to decreasing. Q3 and the last one, true or false, f has 2 points of inflection. How can I tell that f has 2 points of inflection? Where can I find the points of inflection? On a side note, just a quick review, f has points of inflection when we try to find the second derivative and we solve for 0 or a continuous function like this one. Okay, find out where the second derivative is 0. And then we want to also check the signs if it was a table or if it was a graph. Now, I cannot do it here because they gave me a first derivative. Can I find the second derivative? Yes, you can do that. And I'll show you in a second how you do the alternative. So I'm just going to base it on the first derivative, because in the first derivative, you can describe your original function f, and you can also describe the concavity of the original function by looking at the first derivative. Just remember, increasing, decreasing is what you need to use when you are trying to justify that answer. So in order for me to find the points of inflection, I needed to see where my f prime is increasing to decreasing. Because if my f prime, then write it over here. If my f prime is increasing, this tells me that my double prime is concave up. If my f prime is decreasing, this tells me that my double prime is concave down. So there is a point of inflection when your second derivative changes from concave up to concave down, or vice versa. Therefore, there is a point of inflection when your f prime is changing from increasing to decreasing, or vice versa. So I'm going to look at here. This is f prime. This f prime is changing from increasing to decreasing and decreasing to increasing. So that means how many points of inflection? Yes, there are two. One over here and the other one over here. So let's find those values. I'll say F has, we're going to say true. There are two. F has 2 points of inflection. And I will solve them. What are they? At x equals, let me see, at x equals, well, I've solved for the maximum earlier. The maximum was 1 point, this one, maximum of that point right there, which is our first bump. I got it, 1.2533. And at the minimum over here, so I can do second trace, this time minimum, and go all the way down. Stop here before the minimum, and then go all the way after the minimum, press enter. And that is what, 2.1708. Zero, 2, 3. You can stop here at 2.170 or 2.171 if you like. Because what's going on with our F prime? F prime changes from increasing to decreasing. And decreasing to increasing at x equals 2.170. Okay, you can write this out, increasing, and the word decreasing as well. I'm just being lazy. All right, next one is, what is another way to do this? Can I solve for the second derivative and just look at the zero of my second derivative? Yes, this seemed to be an easy second derivative. So I have the first derivative, which is equal to sine x squared. I can solve for the second derivative easily over here, although it's just an extra, it's extra use of your time if you do that. The derivative of sine is cosine. Copy x squared. This is chain rule times 2x. So this is my second derivative here. Find out where is the second derivative. Find out where is the second derivative crossing the x-axis. Okay, so let us do that. Enter that function in. This is the same as Q3. Okay, so I'm going to change my function. This time I'm going to do 2x cosine x squared. Close. And then graph. And then we want to look at where does it cross the x-axis. There you go. F double prime is 0 here, and it's 0 there. So solve it. F double prime of x is equal to 0 at x equals, second trace, 0. And I bet it will be the same one as our maximum in F prime. And that is 1.2533. And minimum, or this 0 right here, second trace, 0. Get closer to that. You can actually just plug in an X in there, but I like to use my right cursor. Go straight, that's my left bound. Now move to the right bound, press enter. And X equals 2.1708, etc. So it's the same answer. Okay, but if you were me, if I were you, that's what I meant. If I were you, I will just simply use F prime, so I don't need to do that extra derivative and then solving for the 0, because they are equivalent, okay? They mean the same thing. The reasoning will be F double prime is 0 here, and then of course, F double prime changes from positive to negative this time. It's no longer F prime changes from increasing, decreasing, because we are now referring to F double prime. In order for our F double prime to have a point of inflection, if this is our f double prime, let's say this is a certain x, there has to be a change in sign or vice versa. But for f prime, I can write it as increasing to decreasing to increasing. Okay. All right, that is it for today. I hope that you try to pause and do it on your own so that you can master how to use the calculator, especially for those parts in the AP exam where it is required. There are multiple choice questions where you are required to use the TI calculator and free response questions as well. All right, have a good evening. It is 8:48, February 18. Have a good night. And stop. Where's the stop recording?